Let's now integrate service discovery into our architecture and use it for Elastic Query Service, Elastic Query Web Client, Kafka Stream Service, and Analytics Service, which are the services that communicates. We will first create a new module, Discovery Service, and add a Spring Cloud Starter Netflix Eureka Server dependency. Also add Spring Boot Maven plugin to create a Docker image for the Discovery Service. Then we will create a logback file and then add application configuration. We can run this with a single instance or with two instances for high availability. So we have two config files here. Application YAML and application-single server YAML files. And we will refer to single server config file using profile's active property, so we will use the single server config by default. But we will change the active profile using services YAML Docker Compose file to use multiple instances, as we will see shortly. We set Eureka client properties register with Eureka and fetch registry to true for the peered service and set the instance app name as the service registry cluster. We also set ribbon enabled to false, as we will use Spring Cloud Load Balancer for implementing load balancing. Then set the active profile as single server to load to application-single server YAML file by default. And then we will add two profiles for peering, peer 1 and peer 2. We set the port as 8761 for peer 1 and 8762 for peer 2 for the peering. Then set the hostname as Discovery Service 1 and Discovery Service 2 for each profile, and also set the instance ID to use application name and instance ID with a random port. Finally, we set the default zone and specify the two hostnames that we defined using different profiles here. With this default zone property, we actually create a cluster and say that we will use two instances for Discovery Service, and we let each instance to find each other. For the single server, we set register with Eureka and fetch registry to false, because at startup, Discovery Service itself also tries to register, and if there is no peer, it will get an error. To prevent error logging, we also set com Netflix Eureka and com Netflix Discovery logging to off for a single server, but we don't set to off these properties when we use peering. Then add service registration and Discovery Service application class with Spring Boot application annotation and also with enable Eureka server annotation to make this service a registration and discovery service. Now we will update the services. Let's start with Elastic Query Service. We will first add Spring Cloud Starter Netflix Eureka client dependency and then add enable discovery client annotation to the Spring Boot application class. And also update Bootstrap YAML file to specify the Discovery Service instances, and use Eureka Client Service URL default zone property to set Discovery Service 1 and Discovery Service 2 that we specified in the application YAML file of Discovery Service. Now we will update host file to map localhost to Discovery Service 1 and 2 so that we can use these addresses when we run this service outside of Docker. When we update the Docker Compose file shortly, we will use the hostnames as Discovery Service 1 and 2 as we defined here. Also in the configuration file of Query Service, we set the ribbon enabled to false to work with Spring Cloud Load Balancer. Now let's do these changes for the web client, Analytics Service, and Kafka Stream Services also. Please add the Netflix Eureka client dependency to the POM.xml file, and then add enable discovery client annotation to the Spring application class. And finally update the Bootstrap YAML file to include the peered Discovery Service information. Please do that for Analytics Service, Web Client 1 and 2, and also Kafka Stream Service, along with the Query Service. And finally for Web Client, I will now remove the manual client-side load balancer. Let's go to the Web Client config, and then remove load balancer client annotation. Only left the load balance annotation, then delete the class Elastic Query Service instance list supplier config, and then remove the service ID and instance ID configuration variables. Let's do the same for Web Client 2. And finally, we need to update Elastic Query Service config and change the Kafka Stream Service and Analytics Service URI values from localhost to hostnames, because with Discovery Service, we now need to use service names, and Discovery Service will do the load balancing by looking at the service name and then forward the request to do services with the same name and different ports. Let's now commit and push config service changes first. Then we can run maven install command and then run the docker compose up command. But before that, let's update the services YAML file and add 2 instances of discovery service. We set the ports as 8761 and 8762 and also set the profiles as peer 1 and peer 2. As we mentioned, default profile is single server, which will only use one discovery service, and we can use it for testing discovery service locally. But to achieve high availability, we need more than one instance, and we configure this in the docker compose file by setting the profile's active properties to peer 1 and peer 2. As you can see, we can also set the default zone property, where we also be sure that 2 instances of discovery service mentioned. After running this, let's check the logs of discovery service and also analytics service. And then we can log into the web client and see if everything still works. Then we can check the query service logs. Remember that we have 2 instances and load should be distributed to them. Yes, as we see, client-side load balancing still works. We see the logs in both of the services. Alright, we are done with the discovery service. Everything is in order. Let's implement an application gateway in the next section. Alright, I will see you in the next section.